Now we are at question 5. So for question 5, it is another question about forces. So when we are dealing with a question about forces, you need to be very mindful. Number one, okay, which dimension are we talking about? Which dimension do you focus on? Okay, because in forces, there are two dimensions, either all the horizontal forces or all the vertical forces. So as you can see here in this question, I know that when I read the context of the question is more interested in the horizontal forces P and F and less on the weight or the normal contact force. So as a result, I have not included the weight and the normal contact force here. Okay, I'm only interested in P and friction. Another thing you need to pay attention to is which direction is the object moving or accelerating or likely to accelerate. So in this case, I know that because the object is being pulled by a force P, chances are it will accelerate towards the right. So once you do that, of course, you will know that this is your best friend, your bread and butter of physics, your Newton's second law. So your Newton's second law is actually this guy over here, and you can actually expand Newton's second law by the definition of F net, which is sum of forces. Now, when we talk about sum of forces, we are talking about the forces in the same dimension. So in this case, like I said, the horizontal forces. So when I say sum of forces, you cannot say that, oh, I have P plus F plus W plus N. These are my sum of forces. Cannot. You choose the dimension that you want to talk about. So in this case, all the horizontal forces. Then you can write P minus F on this side. Now here you will have a question or dilemma. Should you use F minus P equals to M times A, or should you be using what I have written over here? Okay, P plus minus F. How do I know which one to be the minus? Well, Newton's second law also say that if your F net is in this direction, your acceleration also must be in the same direction. That's why at the beginning, I told you that it is very important for you to be able to deduce which direction is the object accelerating towards. So in this case, we know that it is accelerating towards the right. So because of that, we know that if it is accelerating to the right, then it must, by extension of logic, that P and A must be in the same sign, positive sign. And then my F will be the negative one. Okay? Now at this point, if you are still having doubt, this is your basic of basic content. You must clarify with me if you are still having doubt. Okay, ask me on the Padlet. Okay, once this is done, then they gave you a graph. So whenever you are dealing with graph, pay attention to the axis. So this is acceleration and this is P. Then after that, my usual habit is that I will check whether my unit has any prefixes. Is it kilonewton, right? Or is it Newton? So that I don't do anything wrong. So here I basically is telling me that, oh, when my forward force P is between 0 to 1, I do not have an acceleration, right? This is A equals to 0, right? So my question to you is A equals to 0 means that the object is stationary? Or does it mean simply that it is moving at constant velocity? Which one? A equals to 0. Does it mean that the object is stationary? Well, I would say that both of these are correct because both of these describe A equals to 0. Now to answer whether the object is stationary or not, or is it moving at constant velocity, not speed, velocity. Okay? Not speed. Okay, I think not nice. Not speed. Okay? Why? I mean, how do I decide whether it is stationary or is it moving at constant velocity? You must ask yourself, Was it at rest or was it moving? If it is already moving, then it will continue to move at constant velocity when a is 0. If it is at rest, it will be stationary. Okay? Like I said, at this point, still don't understand, do come and approach me. Okay, in part A, you are asked, why is it important that your P must be greater than 1 in order to have acceleration? So here you can see that when your P is 1, you will have 0 acceleration, but once your P is more than that, you can see that the line goes up. And you can actually tell from this equation, right? Because down here you can see that your frictional force is 1. So if you complete this, it will be like that. So if you look at this term, okay, if P is 1, what you will get is that you will get 0 in this green term, right? So P must be bigger than 1 in order for P minus 1 to be a number that's bigger than 0. So you just need to explain that, and in physics we allow, oh, excuse me, so sorry, I burped. so sorry, yeah, and I'm too lazy to re-record, so please allow me to carry on. So when you are asked to explain, okay, to explain why this happened, you can just simply write the formula there, or even include some substitution, but you need to elaborate what the mathematic means, right? P must be greater than 1 so that F net is larger than 1. Okay, you can even use this, it's fine. And then after that, please tell me the consequence. Okay, and you should try your best to rephrase. Okay, so this is rephrase. So then B part 1, you are asked to state just the formula. That's why I say 2020 paper is really about recall. So be very careful. Newton's second law is not F equals to ma. Your textbook or many revision book will give you F equals to ma. No. Okay, F is a general placeholder for a force, a general algebra for a force. A pushing force can be called F, but Newton's second law says resultant force, the net force. So you can call this the net force, you can call it the resultant force also can. Same name. I mean same thing but different name. Then for part 2, you are asked to actually calculate the mass. You can make use of this formula over here, but I suggest you to start with F net equals to ma, and then after that you expand it out like this. It is a better presentation. You may ask me, how you know P is 5 and A is 2? Well, you go to your graph, find any point that you like. You can actually read that your P is 5, and then after that you can read that your A is another number. In my case, I pick 5, 2. So once I pick 5, 2, I can substitute in, and then I can find my mass. Remember, 2SF. Okay?